chances for the laboratory quiz. So in question 1, they ask us to choose the correct central value and the absolute uncertainty of these two quantities. The correct one is this one, because we have the central value plus or minus the absolute uncertainty, that is 0.002. And if we add this number to this value, we obtain this value, and if we rest it from it, we get this value. So this is the correct one. In question 2, asks us which one of these measures is more accurate, and the correct one is B, because the absolute uncertainty is smaller, so it gives us like more chance less chance of having a mistake in our measurement. In question 3, they ask us what is the correlation coefficient, and it is the dispersion between the sample and the trend curve, and it's represented by the R. In question 4, asks us about the least squares method, and it determines a mathematical model with the least dispersion between the sample and the fit. So it means that in our regression line tells us how far away are our data points, and if they are closer, we have like more ahí lo corto.
Bueno, pero sigue, o sea, no lo paro.
No lo pares. With this we have our model that has less dispersion between our data. And in question 5, sorry, it asks us where in which option the dispersion is larger, and the answer is the R squared. It's smaller than 1, because the closer the value of R is to 1 is more exact. So here we have that it's smaller, so it's larger, the dispersion. So for the question number 6, we have to find the derivative of the area of the pipe. So here we have the formula of the area. So what we do is that first we elevate this square, and then we find the derivative respect to d. So we have 2d and we can simplify it like this. So here is the derivative of the area, and in number 7 we have to find here we have to find the partial derivatives of this equation here. So what we're gonna do first, we're going to find the absolute value of the derivative with respect to this. So we have n plus the absolute value of the derivative respect with the t. So we're gonna have the derivative of this is going to be t sorry this is like this, T. So here I missed this letter. So after that we take out of our values the factors that are common. Sorry, a ghost in the classroom. So we have the y plus theta. Here it doesn't matter that we have this minus, it's an absolute value, so we can leave it positive. And we have, sorry. And that's how we find our answer. Okay, so for question 8, we have to, well, the problem says that there are 2 students that made the same experiment and asks us which one is more exact, and specifically why the student A had a more exact experiment, and it's because his error rate was minimum, so that means that his results were closer to reality. Then number 9. We understand that when you have to obtain the absolute uncertainty of an indirect measure, you have to use the differential of the function, like the ones we did in previous questions. Here we have that in question 10 that the dimensionless parameters are the correlation coefficient, the error rate, and the relative uncertainty. This means that they don't really have they have unities, but in all the process that we used to calculate them, in the end they get eliminated, so that's why apparently they don't have any type of unity. Then in 11, we get that the parameter used to estimate or determine the relative degree of precision of a measurement is the standard derivation. And
¿No era deviation?
And in question 11, we have that the parameter used to estimate or determine the relative degree of precision of a measurement is the standard deviation. In question 12, we have a question of what is a systematic error, and this means that can be caused by the measurements that have the same degree of error. This means that in all of the measurements that we made in our experiment had like a mistake or a error when we were measuring them of weighting them or something. So for problem 13, we have this equation, and we are going to find the square root of the values that we have here, that is f and mu. So then we are going to, we will, and we have to find an equation for f, so we're going to do is that we're going to eliminate the square roots like this. And we have read a problem that using this equation, we have to find the units of the slope of m and b. So we have here that the g is the f, and also that the x is velocity. So we have that mu is m and x is the velocity. ¿Ya me equivoqué?
No.
¿No?
No, vas bien. Y la fuerza y B son newtons y ya. O sea, estás bien.
Okay, so we have this equation using the values that the problem gives us, and then we can say that mu as it's told, the problem is mass over length, so the m units are kilograms over meters, and the force given by B, and the force is given by newtons. And that's how we get the answer. Then we have in question 14 that they give us this equation and we have to find the relationship between the m and the w, and they give us that the w and the m are both variables and the key is constant. And because the key is constant, the variables depend on it, so the relationship between them is linear. And in the last question, they ask us in this equation what type of graphic we get, and because we're told that the value of p is constant, we know that when we graph it, we're gonna get a constant line that it's a straight line.